So we're back. So I wanted to show you guys the sawhorses that I'm going to be doing this work on. Super proud of how they turned out. These were followed, or I should say these were based on a video produced by a channel called Next Level Carpentry, where this master carpenter does frankly phenomenal videos. His content is outstanding, so if you never heard of him, please check him out. He did a YouTube video on building these super strong sawhorses. I think he called them like apprentice sawhorses or something like that. And so he put them together, did a whole video on how to do it, and then when he was done, he took them to a lumber yard, and they loaded, I think, 16,000 pounds of 2x4 bundles on top of two of these sawhorses, and they survived it. They were barely buckling. So it's truly astonishing just how strong these are. And they're really not that difficult to make. So, basic construction. See if I can focus here. I notched out at an angle here, sort of chiseled it out by hand on either side so that this wedges solidly into that void. 3 long and strong Spax screws, SPAX, if you've never heard of them. It's like the penultimate hardware. They're ridiculously strong. They don't require pre-drilling, even though for the sake of precision in terms of screw placement, I pre-drill holes anyways. But they're phenomenally strong screws, and those are holding the 2x4s to this I-beam construction here. And again, these are Spax screws that are running evenly spaced throughout. So these are not only very, very functional and incredibly strong, but they're also, frankly, I think they're very pretty sawhorses. Way better than the ones I have in my parents' house, where it's just that metal bracket that clamps to a 2x4, and then with a 2x4 screwed to the top. Those are super cheap, super flimsy. These things are outstanding. So I'm going to continue on. So I've got these boards here are the side panels of my cabinet. 3/4 inch plywood, not light. But yeah, it's going to be a solid cabinet. It's also going to be really stinking heavy, but it'll be good. Alright, so here's both boards. These again are the sides of the cabinet. At this point in time, I need to designate which side of these is going to be the inside of the cabinet and which is going to be the bottom versus the top. And so we're just going to mark that on here. Really important thing with making cabinets is that they need to be, how do they call it? Like book matched. So they have to be, and since I have a degree in chemistry, we would call them chiral or enantiomers of one another. They're handed. So even though when they're put together, just like your hands, you don't want to make them both the same, otherwise it's like putting 2 right-handed gloves together. So they need to be handed. So I'm going to cut out the toe kick. If I take both of these boards, and my toe kick is going to be 4 inches long and 3 inches high. So if I make both of these boards identical and draw my toe kick out on that one, just the same as on this one, in the same bottom right corner orientation, and I'm designating, you know, this face here as the inside. Well, when I flip this one up so that the inside is oriented inside, this toe kick is going to be in the back of the cabinet, and that toe kick is going to be in the front of the cabinet, aka you just failed. At this stage, it's not that big of a deal. If I want to consider this the outside of this board, or this face of the cabinet, and this one the inside, if I flip them both up the same way, the toe kick will be in the front bottom on both boards. But I'm going to designate this as the inside, and they're on both sheets here. So the toe kick on this one needs to be in the bottom right corner, but the toe kick on the other sheet here, which is going to make up the left side of the cabinet, this needs to be on the bottom left corner. So that when they are folded up so that the inside respectively is in the same orientation, the toe kick it's in the front bottom on both of them. Once I cut dadoes into these sheets for the backboard and for the shelves, then it becomes really critical that I make sure those are all in the proper orientation, because with this being the inside of the cabinet, I'm going to do a toe kick down here. Therefore, this is the front of the cabinet. I'm going to have a dado a ½ inch from this edge, from the back wall of the cabinet, if you will. There's going to be a ½ inch wide dado to accept a ½ inch wide sheet of plywood that I've got behind the camera. So I'm going to go ahead and draw out these toe kicks. The toe kick is just that little step that's in the front of your cabinets. Almost all cabinets have them. They are kind of optional if you're getting custom cabinetry. But if you want to work on your cabinet and your toes are sticking out, you know, several inches from the front of your body, you would naturally have to be leaning over every time you're working at that cabinet if you didn't have a toe kick to accommodate for how much your toes stick out past your knees or your shins. So you want, when you're using that cabinet, you know, your knees or shins or whatever would be resting up against the doors of the cabinet. Your toes would be essentially slightly underneath the cabinet, and you'd be able to have your body right up against the work surface, so it's much more comfortable. So that's what we're doing now. I'm going to get back to you when I'll go ahead and cut these out, and then I'll get back, because you're not really missing much. Alright, so the toe kicks are cut. There's a piece of cake. Again, this is designated as the inside, this is designated as the bottom. And so when I flip these up to orient the inside to the inside and the bottom to the bottom, the toe kicks are perfectly lined up. So now, the next step is to mark up and line up my dadoes. And if you don't know what a dado is essentially a really wide cut, so a typical saw blade, such as the saw blade that is on my radial arm saw, that cuts a 1 inch wide kerf, is what it's called. A dado can be as wide as, I don't know, I think my staff goes up to 7/8 of an inch total width. So you can cut a really wide swath of wood, a really wide groove, and with a dado you are not cutting all the way through the wood. You're cutting a channel. So this is 3/4 inch plywood. I'm going to cut a groove that is 1/3 of that, so that allows me 2/3 the strength of the board itself. So I'm going to cut a 1/4 inch deep groove, and it will have a width of a ½ inch. And the reason for that is because I have a backer board that's going to make up the back of the cabinet. It's ½ inch thick plywood. It's not as thick as the sides. I don't really think it needs to be as thick as the sides, and cost savings too. So the groove, you're going to have that backer board, and both of these are going to be screwed into that and glued that channel will secure the backer board to both sides. And then from there I need to figure out like a support for the front of the cabinet. We'll figure out how to do that. For now I'm going to line up the groove that I'm going to cut, the dado. It's going to be a 1/2 inch away from the back of the board. Again, it will be a 1/2 inch deep. I'm sorry, it will be a 1/2 inch wide and a 1/4 inch deep on both boards. So the dado is going to be, this is one board, so this is the back of that board, and this is the back of that board. So the dados are both going to be run up that way. The next dado that I'm going to need to cut will be for the bottom support. So then at that point the bottom will be supported, the back will be supported, and then from there it's just getting the top squared away. So I'll come back when I've got the dado drawn out, and then I will also shoot the cutting of that dado. So here's an example of a dado. I've got them all mapped out on the boards, but before I cut them I wanted to kind of show you exactly what a dado does. This is just a piece of 1/2 inch plywood. With setting up a dado, you are given 4 blades. I'll go ahead and show it to you. I'm sorry, not 4 blades, 5 blades. You have, these are called chippers. So it's a blade essentially with 2 teeth on it. And then you've got your inside and outside blade. So we've got 3 of these in the whole stack and 2 of these. So where it is marked, that's the outside face of it. And so you assemble this based on how wide you want to cut your board. So if you just take 2 of these blades right here, these inside outside blades, put them together, you're going to cut a 1/4 inch wide kerf, or 1/4 inch wide groove in your workpiece. If you add a chipper, you add 1/8 of an inch. And then from there, it's 1/8 of an inch per chipper. So a 1/2 inch plywood is not exactly a 1/2 inch. When you go to your home goods store like Home Depot or what have you, when you look at it, it'll tell you that it's actually 15/32 of an inch. So 16/32 is a 1/2 inch, 15/32 is a 1/32 of an inch shy of that. And so if I took these inside-outside blades and 2 chippers, that would equal a 1/2 inch. I would have a 32nd of an inch of slop. I don't like slop. I like things to be nice and snugly fit. So what also comes with a dado stack is a kit of shims. And these go down to 0.1 millimeters. And that is phenomenal for setting up a dado stack to give you an exquisitely tight fit. So the result of that was, here's my demo 1/2 inch sheet of plywood, here's my dado groove. I get a beautifully tight fit. That's awesome. Conversely, when I set this up initially, I set it up as a 1/2 inch. So I had 2 chippers, inside outside blade, and no shims. And this was how that fit. That's no bueno. That's way too much slop. That's how I like things to fit. So this is how this is going to be set up. And I'll go ahead and pause it here and get back to you when I get the blade apart, and I'll show you how you put together a dado stack on your saw for ripping a 1/2 inch dado. So here's our radial arm saw with the blade guard removed. We're going to go ahead and change out the blade and put the dado stack on. So making note of the blade orientation, it's cutting toward me. I already loosened this up. It's important to note that this is a left-handed thread, so the whole concept of lefty-loosey, righty-tighty does not apply here. It's righty-loosey, lefty-tighty. So I'm turning this to the right and loosening it. And again, make a note of our blade orientation. The teeth are coming toward me, and then, so we're going to put the dado stack on the same way. It'll cut a lot better that way. So this is going to be, so again, I think I mentioned this earlier, the side of the blade has got lettering print on it. That print always goes to the outside of the dado stack. So if I, example, put this on this way, the teeth are going the wrong direction, they're going away from me. So this goes on the outside of the stack. And we've got two sets of shims. I've got this, again, I don't know how wide this is, I think it's 2 millimeters. But I got this thick shim. Put this on here, and we're going to get our chipper blade. We're going to put that on here, again, noting the orientation of the teeth coming toward me. And then lastly, we're going to put our other stack of shims on. With these thinner shims, it's kind of finicky because, you know, the whole diameter is about the same as that arbor shaft, and because of the threads on the arbor, those really thin shims can get stuck in there, and so you want to make sure that you're not going to end up bending them when you tighten things up. It should be okay. And again, we've got the print now on the outside of the dado stack. Now we're going to align the teeth such that we don't have any binding between the cutting blades and the chipper blade. And I'll bring the camera around so you can, actually no, I think I'll just rotate this and you should be able to see, hopefully, well enough. We'll put our large washer on here. And put our nut back on. Again, it's righty, loosey, lefty, tighty. I've been playing with this stuff long enough that I never use that manometer. We're going to slug it up. Hopefully you guys can see this. So we've got, in this region, the chipper blade is absent because the chipper blade is just a thin blade. So here there is a large gap in between the two outside cutting blades. Rotating it around, now we're at the chipper blade. Now we've got the two outside cutting blades here. Here's the chipper. Here's sort of the, you know, chip removal part of the chipper, and that's lined up with the chip removal part of the next teeth on the outside and inside cutting blades. And so looking around, nothing is binding. There's a gap between everything, which is exactly what we want to see. Now the gap between this outside cutting blade and the chipper is thinner than the gap between the inside cutting blade and the chipper, and that's because we're using I think it was like a 2 millimeter wide or 2 millimeter thick shim on this side and only a 0.8 millimeter wide shim stack total on this side. That doesn't matter because the width of the teeth on the chipper is greater than the width of that whole gap. So the chipper makes up for everything, and in addition to that, the cutting blade teeth, they overlap on the inside as well, so that at the end of the day, the entire width of this is taking out material. You're not going to have like a little strip left over in between where teeth are not cutting. So the whole width of that 15-30 seconds thereabouts is covered. So I need to orient this blade to cut a half-inch away from the fence, because I have my sheet goods on here. This is one of my sides. The back of this cabinet is up against the fence, and the dado channel that I want to cut is a half-inch in from there. So I'm going to get the blade guard back on here. I'm going to get this thing lined up so that we're a half-inch away, and then I'll get the depth set so that I'm just barely kissing the plywood here. And I think next time I turn the camera on, I'm going to be ready to pull the trigger on this thing and rip this. Right.